Hello my dear learners, welcome to my video lecture on power transmission. This video lecture is presented by me, Shamant, working as an assistant professor at Global Academy of Technology. So why is it important for you to understand power transmission? And in today's video lecture, I will be explaining about belt drives. There are various drive systems which are available for transmitting the power, but out of that, the commonly used drive system is belt drives. It has its own advantages, it has its own disadvantages and application as well. But we'll stick on to the discussion of belt drives only. So there are chain drives, there are gear drives, there are rope drives as well. But first let us understand what is the belt drives and then we'll move on to other drive system. So let us begin our today's lecture. Introduction to belt drives. So it is very important for you to understand the belt drives exactly and then move on to understand different things of the belt drives. So first and foremost, the belt drives are a type of frictional drives. So here you need to understand the frictional drives which are used for transmitting the power. They are quite popular owing to their high durability and reliability. Why is it popular? It is because of the high durability and the reliability that it gives for the usage or the transmission of the power. They are comparatively easy to install and maintain and generally are durable and viable in the long run. When you compare belt drives to the other drive system, these are the factors or these are the parameters on which you can actually rate the belt drives higher than the others. Belt drives are used to transmit power between two shafts which do not have a common axis. You can see here, one is a driving shaft, the other one is a driven shaft. The two shafts have a different axis. When they have a different axis, then if you want to transmit the power from one shaft to another, then you can easily do it with the help of the belt drives. Factors that determine the power transmission are the velocity of the belt tension between the pulleys and the angle of contact between the pulleys. These are the important factors that determine how exactly power can be transmitted between two pulleys using a belt drive. So this is about the introduction of the belt drives. We need to understand that there are different types of belt drives as well. There are three types of belt drives depending on the speed of the belt. We'll see one by one what are they. The first one is light drives. Light drives are used to transmit small powers at a belt speed of 10 meter per second as in agricultural machines and small machine tools. So where do you use light drives? It is used when a belt speed is 10 meter per second and it can be used for lighter applications such as in agricultural machines and small machine tools. So you can see the belt which is wound over two pulleys and one pulley is mounted on the shaft of the motor and the other pulley is mounted on the shaft wherein the machine is operated, and this is a belt drive. The second type of drive is called as medium drives and they are used to transmit medium power at belt speeds over 10 meter per second but only up to 22 meters per second as in the machine tools. Third type of drive system is heavy drives and they are used to transmit large powers at belt speeds over 22 meter per second. Generally they are used in compressor and generators. So you can see a generator here. So a belt is wound over two pulleys and then it is used to produce larger power. When you have to produce a larger power, then you have to use a heavy belt drive. So these are the classification or different types of belt drives. Now you need to understand what are the different types of belts available in the market. The first type of belt is flat belt. So flat belt, you know that it has a flat cross section and they are mostly used in factories and workshops where a moderate amount of power has to be transmitted from one pulley to another when the two pulleys are not more than 8 meters apart. Even this is very much important for you to remember. Flat belt is used to transmit moderate amount of power from one pulley to another when the two pulleys are not more than 8 meters apart. That means the distance between two shafts is told, that is 8 meters. And there are different types of flat belts available. They are open belt, cross belt and compound belt. We will see what are these types of belts in the later slides. So this is a flat belt. This is how it looks. The cross section is rectangular and you call this belt as flat belt. The second type of belt available is V belt. V belt is mostly used in the factories and workshops, yes, where a moderate amount of power is to be transmitted from one pulley to another. But here, look at the distance when the two pulleys are very near. Flat belt is used when the two pulleys are 8 meters apart, whereas V belt has to be used when the two pulleys are very near. This is a type of V belt. So it does not look exactly like a V, but it is somewhat trapezoidal. The third type of belt available is circular belt or rope belt. They are mostly used in the factories and workshops where moderate amount of power is to be transmitted from one pulley to another when two pulleys are more than 8 meters apart. So this is how the circular belt looks. It is something like a rope wherein a long rope can be connected together or joined together to form the drive, and then you can mount it on the pulley and then you can use it. And it clearly says it can be used to transmit the power when two pulleys are at a distance more than 8 meters apart. If it is within 8 meters apart, then you can use flat belt, but if it is very near, you have to use V belt. So these are the type of belt available in the industry which are used to transmit the power. Different types of materials are used for belts. Let us see one by one what are the materials that are used for belt. The most commonly used material for belts is leather belts, and they are made from 1.2 to 1.5 meter long strips which are cut from either side of the backbone of the top grade steer hides. So leather belts are generally used and most widely used belts for all the applications. So this is how a belt drive looks. It is just wound on the pulley, and wherever the power has to be transmitted and between the two shafts which is 8 meter apart. Then you have cotton or fabric belts. Most of the fabric belts are made by folding canvas or cotton duck to 3 or more layers and stitching it together. So the importance of the cotton fabric is that it can be used in warmer temperature, and also if there is some dampness in the belt, even then you can use the cotton belt. So this is the cotton type of belt which can be used for the transmission of power. Then the third material what can be used for the belt is rubber, and these are made from the layers of fabric impregnated with rubber composition and have a thin layer of rubber on faces. So this is how a rubber belt looks like, and generally it is used for V belts because of the advantage that it gives, and also it does not slip very easily. The fourth type of belt is balata belts, and they are almost similar to the rubber belts except that the balata gum is used in place of the rubber, and this is how a balata belt looks like. So these are different materials which are used for the belts: leather belts, cotton or fabric belts, rubber belt, and then balata belts. The classification of the flat belt drives. So the first type of flat belt drive. So how many types of drives are there? One is flat belt, the other one is V belt. So that is what we have discussed in our previous slide, whatever was there. When you just types of belts, flat belt, V belt, and then circular belt, that is what we have understood. And in flat belt, I told you that there is open belt, cross belt, and then compound belt. So we'll see one by one what are they. So the first type of drive is open belt drive. They are used with shafts which are arranged parallel and rotating in the same direction. There are two important points that you need to remember here. Open belt drive is used with the shafts which are arranged parallel. So that means you have one shaft and the other shaft which are parallel, and when they are parallel you can use these type of drives. And it says it has to rotate in the same direction. So the driver A, so you can see here the figure, one pulley is called as driver, the other pulley is called as driven. Generally the driver pulley is of larger diameter and the driven pulley is of smaller diameter, and the pulley is wound over the two pulleys, and one side of the pulley is called as tight side. That means when the driver pulley is pulling the belt from one side, that side is called as tight side, and then the delivery region, when the driver is delivering the belt to the driven pulley, that side is called as slack side. So you have to understand what is a tight side and then slack side. So this image is a top view of the belt drive. So the driver A here, this is the driver A, it pulls the belt from one side. From one side it is pulling, and that is the lower side RQ, and delivers it to the other side, that is upper side LM. And the lower side here in this particular figure is called as tight side, and then the upper side is called as the slack side. So you can see the animation of the open belt drive. So the tight side is here and then the slack side. So this is where the shrinking happens. So here the shrinking is taking place, and then here the stretching takes place, and then it pulls and then delivers it to the other pulley. So here this is the driver pulley. So whatever we saw here, driver, this is the driver pulley and this is the driven pulley. This pulley is driven by the driver pulley. So this is about the open belt drive. The second type of belt drive is cross belt drive. These are used with shafts arranged parallel but rotating in the opposite direction. When you have two shafts rotating in opposite direction, then you can make use of cross belt drive. You can see here A is the driver, B is the driven pulley, and both are rotating in opposite direction. This is rotating in clockwise direction, whereas B, that is the driven pulley, is rotating in the anti-clockwise direction. When you come across this type of situation, then you can make use of a cross belt drive, and that cross belt drive, the driver in this particular belt drive, that is the cross belt drive, the driver A pulls the belt from one side, that is from RQ. From this side it pulls and then it delivers it to the other side, that is to the side LM. So belt RQ is known as the tight side here. This side is called as the tight side, and then belt LM is called as the slack side. So a small animation of the cross belt drive. You can see here it is pulled from one side, that is from this side it is being pulled and then it is being delivered in the other side. So this is about the cross belt drive. There are different types of belt drive available, but for our discussion we have to restrict ourselves to understand open belt drive and then cross belt drive. So that is what we'll be discussing further in our slides, and also you will have the derivation of open belt drive and the cross belt drive. The other type of belt drives generally used is belt drives with idler pulleys. A belt drive with an idler pulley is used with shafts arranged parallel, and when an open belt drive cannot be used due to small angle of contact on the smaller pulley. So here for a particular condition you are using the idler pulleys. So what are those idler pulleys? So apart from the driver and the driven pulleys, there is one more pulley which is added in between the two pulleys, and that is added because when the open belt drive cannot be used due to small angle of contact. When the angle of contact is very small, then you use this idler pulley to subject the pulleys or the belt into certain tension. That is why you use the idler pulley. And this idler pulley, which is placed on the slack side, this has to be placed on the slack side of the belt, exerts pressure on the belt, thereby increasing the arc of contact and also tensions in belt. So idlers are always used to increase the arc of contact and also the tensions in the belt. So when you do not have a proper tension in the belt might slip out from the pulleys. So to avoid that and to have a proper tension and also proper arc of contact, the idler pulley is necessary to be incorporated in between the two pulleys. So the first image here depicts the belt drive with single idler pulley, and you can also make use of multiple idler pulleys. And when you make use of multiple idler pulleys, this is how the system looks like. You have one driver and one driven, and the rest all are idler pulleys around which or over which the belt is mounted, or it is just mounted on the belt and then it is completed. So you can see here in the 3D image, this is how the idler pulleys and then tensioner pulleys are present in between the driver and the driven pulley. So whenever the tension comes down, this comes into picture and then it increases the tension of the belt so that the power is transmitted in a efficient manner. The next type of drive is compound belt drive. A compound belt drive is used when power is transmitted from one shaft to another through number of pulleys. So generally, this compound belt drives is used when you have more distance, when you have to transmit the power to a larger distance than the distance whatever is available to you. At that point of time, you make use of compound belt drive, and generally you will have one driver around which the pulley will be wound, and then there will be one driven, and to the shaft of the pulley which is mounted, that is the driven pulley mounted, there is one more pulley which is added on the same shaft, and from that pulley there is the belt which can be continued to the another shaft. So this is how a compound belt drive looks like. You have the first pulley here, which is the driver pulley, and then the second one, you can see the top view. This is the top view. The top view of the smaller pulley looks like this, and then to the same shaft, here, there is one more pulley which is attached or mounted, and then you are transferring the power to the other shaft. So here the power transmission is taking place from this shaft to this shaft. When you have to transmit the power to a longer distance, then you can make use of compound belt drives. So a small animation here showing the working of the compound belt drive. So this is the driver, and here you can see the driven. So from here to here the power is being transmitted to the same shaft. There is one more pulley which is added or mounted, and then it is transferring to the other shaft. So this is how compound belt drive works. Then the next type of belt drive is stepped pulley belt drive, and generally the stepped pulley, or it is also called as cone pulley, it is used for changing the speed of the driven shaft. When you have to change the speed of the driven shaft, then you make use of stepped pulley drives. So this is accomplished by shifting the belt from one part of the steps to the other. So here this is the main or driving shaft which is connected to the motor. When the motor is rotating at a particular speed, say for example the motor is rotating at 500 rpm, but on the driven shaft you do not want 500 rpm, you want lesser than that. At that point of time, you make use of stepped pulley, and then you shift the belt accordingly, and then you get the required speed whatever is necessary. This is the animation of the stepped pulley or cone pulley drive. So here you can see the larger pulley on the driver shaft is mounted to the smaller pulley on the driven shaft. So likewise you have 3 or 4 speeds which can be toggled as per the speed which is required. That is the main use of using stepped pulley drive. So you need to understand some of the definitions in belt drives, and the first important definition is velocity ratio. This is also used in the numericals that we solve in the later part of our syllabus. So what is velocity ratio? It is the ratio between the speed of the driven pulley, that is the follower, and the speed of the driving pulley, that is the driver. When you take the ratio of the speed of the driver pulley and then the speed of the driving pulley, then you get a particular value, and that value is the ratio between the speeds of the driven and driver pulley. So generally we take D1 as the diameter of the diameter pulley here. So this is the driver pulley, and the diameter of the driver pulley has to be noted down, and then D2 is the diameter of the driven pulley. So the shaft which is at a particular distance from the driver pulley, so the diameter of that driven pulley is to be noted down, and then you will be knowing the speed of the driving pulley. So N1 and N2 is known. Speed of the driving pulley as well as speed of the driven pulley will be known to you. So when you have these values, then it is very easy for you to calculate the velocity ratio. It says the ratio between the speed of the driven and speed of the driving pulley. You need to just take the ratio of N1 and L2. So how do you take that? So it is N2 by N1. So speed of driven pulley. What is driven pulley speed? N2. So N2 by N1, which is equal to the diameter D1 by D2. So speed of driven by speed of driver is equal to diameter of the driver divided by diameter of the driven. So when you take these ratios, you will be getting the velocity ratio. So there is a small note that you need to remember. When the thickness of the belt is considered, if you have to consider the thickness of the belt, then you need to add the thickness to the diameter. That is, if D1 is the diameter of the driving pulley, you need to take the diameter as D1 plus the thickness of the pulley, and likewise even for the diameter of the driven pulley, D2 plus T, and then you have to calculate the velocity ratio. This is one of the important thing that you need to note while calculating the velocity ratio. Generally, the thickness will not be considered. Suppose if the problem says you have to consider the thickness of the pulley, then you have to make this in, you have to remember this particular point and then add the thickness. The next definition is creep. So when the belt passes from the slack side to the tight side, a certain portion of the belt extends and it contracts again when the belt passes from tight side to slack side. So generally what happens is, when there is the continuous motion between two pulleys, that is the driver pulley and then the driven pulley, the belt which is mounted on the pulleys might have certain changes which arises due to the pull and push, that is the contraction and then the expansion taking place in the belt. Due to these changes of length, there is a relative motion. Because of that changes, there will be a relative motion between the belt and the pulley surfaces, and that relative motion is termed as creep. So what is creep? It is nothing but the relative motion which occurs due to the contraction and then expansion of the belt at the tight side and the slack side. So that motion leads to the changes in the length, and that is called as the creep. Slip. The power transmitted from one shaft to the other depends on the frictional grip between the belt and the pulley rim. So always when you have mounted the belt on the pulley rim, there is always a friction present in between two objects or the two things that you are taking into consideration, that is the belt and the pulley rim. So here you can see here a belt is mounted over two pulleys, but sometimes the frictional grip becomes insufficient. There are chances that the grip, that is the frictional grip what is required to hold the pulley on the rim of, hold the belt on the rim of the pulley will not be sufficient. That causes some forward motion of the driver without carrying the belt with it. This is called slip of the belt and is generally expressed as percentage. How do you express slip? You express in terms of percentage, and that is calculated as well. So it is included in the calculation of the velocity ratio. So when you are calculating velocity ratio, you need to keep these points in mind. One, if the thickness is given, you need to add thickness to the diameter, that is D1 plus T or D2 plus T. And also they might ask you consider the slip. When you consider the slip, then you need to use this formula, that is N2 by N1 is equal to D1 by D2 into 100 minus S divided by 100, where S is nothing but the percentage slip. Some of the advantages and disadvantages of flat belt drives. One of the advantage of the flat belt drives is it can be used when the center distance between the shafts is large. When the center distance between the shafts is not large, when it is too small, then it cannot be used. That is one of the disadvantage. Speeds can be varied by varying the diameters of the pulleys. So you can vary the speed by varying the diameter of the pulley. And one of the advantages is that it has very low operating cost. And then the smoothness of operation and ability to absorb shocks due to elasticity of the belt. So it can absorb the shocks which happens due to the elasticity of the belt. The disadvantages: due to slip in belt drives, exact velocity ratio cannot be maintained. If you have to maintain a proper velocity ratio between two shafts on which the belt is mounted, then it might not be possible because of the slippage. Only moderate power can be transmitted. You cannot transmit larger powers. It is used for transmitting power only between parallel shafts. This is one of the disadvantages of the flat belt drives. Now we'll understand what is V-belt drive. So we will be discussing only flat belt drives, that is the derivation is a part of that. So this is only for your knowledge. How exactly V-belt are different from flat belt? To understand this, I am just giving you a small gist of the V-belt drives. V-belt drives are usually endless and it is trapezoidal in cross section. The included angle for the belt is usually 30 degree to 40 degree. The belts are made of fabric and cords molded in rubber and covered with fabric and rubber. In V-belt drive, the rim of the pulley is grooved. See here, the major change that you can see in V-belt drive is that the pulley rim is also grooved, whereas the belt is also grooved on the bottom end. Whereas in flat belt drive, there are no grooves. It is just mounted on the pulleys, so as to accommodate the V-belt. Grooves increase the grip on the pulley. So what does the groove do? It increases the grip on the pulley, thereby reducing the chances of slipping. In V-belt drives, the chances of slippage is very lesser. The ratio of belt tension in V-belt is given by T1 by T2 is equal to e to the power of mu theta by sin alpha. So this is only for your remembrance. In flat belt drives, while I explain you the derivation, I will explain about how you get the, or how you arrive at the equation which is required to calculate the ratio of the belt tension. T1 and T2 is nothing but the belt tension. So this is how a V-belt drive is mounted on two pulleys. This is the driver and this is the driven pulley, and you can see the grooves here. So grooves which is present on the rim of the pulley. Advantages and disadvantages of V-belt over flat belt drives. V-belt transmits more power because there are no chances of slippage. Slip between the belt and pulley is negligible as compared to the flat belt drive. It can be used to transmit power for short center distances, and it has higher velocity ratio compared to flat belt drives. The disadvantages: it is not suitable for larger distance because it can only accommodate lesser than 2 meters. V-belts are endless, and also the pulley has to be provided with grooves, hence construction is complicated. If you have to create the grooves on the rim of the pulley, then it takes lot of effort, lot of machining is required. So slightly complicated. The fabrication or the production of the belt drive system is quite complicated as compared to the flat belt drives. So thanks for watching. I hope you have understood the introduction of the belt drives. So moving on further, in my next video lecture, I will be talking about, I will be deriving the equations for open belt, cross belt, and then ratio of belt tension. If you like this video, do subscribe my channel Inquisitive and also share it among your friends.